Hello. Who do we have with us today? Give me 1 second. Just to make sure I have a lot of things set up to go. Maximize that. And voila. Here we are. Back to the avatar. Hello everyone. It's let me make sure I'm in a slightly less awkward position. There we go. I think that's all right. Hello everyone. And hopefully I'm going to reset tracking. You're going to see behind. Actually, give me a second. Nope. Sorry, just need to readjust something quickly. Okay, I think everything's good. Hello again. So, today we're going to be going over World Mason, which let me go ahead and actually pull that up so I can show it off. Over here. Sorry, I'm trying to make sure I have everything I need on visible to me. All right, I think we're doing good. Sam, I think is this your first time in one of the streams? Admittedly, I haven't done a stream in a while. But it's nice to see you. Sam Cheshire says, "Love watching your videos and have inspired me to make my dream game." That makes me very happy to hear. I know it's something I haven't really thought about because until I started making devlogs, but how many people are really enjoying seeing the stuff I make and it's inspiring them, which that was very much the point, so that more people would get into actually working on stuff. So I'm very happy to hear that. So thank you very much. All right, let's see. Okay, so World Mason, that's what we're talking about today. All right, so World Mason is a new plugin I've released on the Unreal Engine Marketplace. You should be able to get it if you just go to Studio Syndicate there and find it. So what World Mason essentially is it's a bunch of functions that that essentially are ways of populating meshes inside an actor in ways that essentially save you time having to manually place them, and essentially provide an easy way to create things like walls or buildings or fences or stairs and stuff like that, where instead of needing to kind of manually create a new blueprint for that every time, you could just use a few functions to speed that process along, and then create all sorts of different. We got some demo structures here, all sorts of different structures. So we show off some of the functions we got here, and that's kind of the stuff we'll mainly be going over today. I will be using an asset pack, which let me pull up. Well, I'll show you, but a free asset pack. I don't know if it's actually free, but the asset pack to kind of demonstrate how some of the stuff is done. You can also go and check out the video that specifically shows kind of how some of the stuff works. This is one of the examples of a sort of a spherical building. It has something I've showed off in devlogs, which is the spline. Well, not spline volume, but essentially it's like a dynamic spline area. And yeah, this stuff is that you're seeing on the screen is included. It's demo stuff that's included with the plugin. And I'm going to be going over specific use cases of it right now. So let's close all that and go into the demo map. Well, let's make sure I actually have a content browser available as well. This might be a shorter stream. I imagine it'll be under an hour because I'm just going to be going over some of the... This will sort of be the current tutorial, even though I think stuff is fairly clear, but this will kind of be a reference point for people who want some specifics. So yeah, I've imported this Asian village map. which I realized I didn't preload so I may have to load shaders and stuff just to use the assets to demonstrate. Um, 1 second. Gotta get a drink. Keep yourself hydrated and all that. All right, so provided this hurries up, I'll be demonstrating how all this stuff works. Okay, this is gonna take a minute, because I realized I should have preloaded this beforehand. So, how's everyone doing? Seemed like people were really enjoying the last devlog. It's doing really well, so that's nice to see. I'm glad to hear that. There was a lot of comments, by the way, on the last devlog about making some of the tools I used available on the marketplace. So I'm going to try to be doing that. I've released the advanced spline volume, which is the system that I made for creating like more specific blocking volumes and invisible walls. Though it's more general use where it's not just for that. You can use it as a volume for all sorts of stuff. And I have a couple other things. I'm working on I've started working on a version of the mini map for the marketplace. Obviously, I'm priority soon will be trying to get Omega updated to 5.1 and just get the latest stuff available to it, because I realized some of the stuff that's currently on the marketplace, the Omega add-ons I've had, are kind of broken in that some of the functions they need to use are not. The current version on the marketplace doesn't utilize those functions, have some bugs. So I need to work on getting the new version of Omega on the marketplace, and then also I want to update a lot of those plugins because they're missing a lot of the new features like data items and stuff like that. So this is actually taking a really obnoxiously long amount of time. I think I'm going to restart the thing. Give me a second while I go ahead, and I'm going to restart the project. Oh boy, this is taking much longer than I expected. End task. Come on. Do. All right. There we go. Demo time. I didn't have music going. I just realized. Oh, that's fine. Ooh. Oh, sorry if you hear any sniffling. Sorry, got a bit of congestion going on. It's kind of dry where I am, so it's not great for my nose. All right, back to the map. Here we go. So instead of trying to load up the demo map, I will just show you kind of how things work. So some of the stuff I demonstrated mainly are stairs, houses, and walls, or fences, because fences kind of work the same way. So let's get started by making a new blueprint, because that is where you will start. For now, I'll just start making a wall called a World Mason wall demo. All right, so primarily World Mason makes use of mesh instances as a way of saving performance. Though that's the main component it'll use in an actor. Though depending on the function, it'll also make use of dynamic meshes, which are unique to Unreal Engine 5. And oh, that reminds me, in order to use, which I believe is automatically being added, in order to use World Mason in general, you will need to have the geometry. Let's see if I can find it. The geometry scripting plugin installed. This allows essentially for creating procedural meshes in Blueprint. Wait, no, don't disable it. So, one of the first things you can do is when you load this up, just look up World Mason, and you will see under World Mason a bunch of different functions that you have access to. So I think for this time we're going to go ahead and make a wall. And for that, I think how I'm going to make a wall is we pull up here. Walls and fences, I kind of make them out of 2 points. You have the actual wall, and then you have the separator that go in between the sections. So I will demonstrate 2 ways I think to do that. The first one is the most common way is just you have a wall and a section mesh, and you just repeat them all around. Um, let's say for a section, let's use. Well, actually, let's go ahead and first add mesh instances, because you'll need a different mesh instance component for each each type of mesh you're going to use. So let's say mesh instances, and this will say wall, and then we'll add another one. We'll call it separator. For the separator, we'll say, I think they're actually called columns. Is that it? Yeah, we'll just go ahead and add column. And for wall, let's just look up wall. And I think we'll go with that. And let's drag an example of this into the map. So, in the construction script is the main place you're going to want to put all these functions. And in this case, the function I'm going to be using is called, let's see, I think it's add mesh instance. It's been a hot minute since I was working in the editor, so I'm trying to remember off the top of my head what it's called. Add mesh instances along driver. Here we go. So what this is going to do is is going to take in a vector, which is going to be essentially, it's going to be taking whatever the local position in an actor is. Well, I'll just show you. A vector driver is typically just a. Let me back up for a second. I'm kind of assuming you know a lot of things about the editor and how to use it that you may not know. So let's try back up. Whenever you add a vector variable to an actor, you have the option when it's an instance editable to add this show 3D widget. And some of this you may already know. When you do that, then the actor will actually have this little widget you can drag and pull around, typically called a driver. That's what I've named it. And you can drag it around in editor. Excuse me one second. Gotta blow my nose. Pardon me. All right. So, I'm going to go and reset the position on that. Now, in World Mason, we're going to take that driver and we're going to use it to add a bunch of mesh instances in a organic way. And first I want to add walls. So what I'm going to do is plug in the walls, use that driver, and just add this in. And now, nothing's happening. Well, we got to add in a couple of things first. Number one, we need to know how far apart each section of the wall we want to be. Now, in my experience, especially with this asset pack, it's typically around 400. It's basically whatever the size of this mesh is. And there's a few ways to do this. You can just add it in manually, which is, if you know the size, is how I like to do it. Though if you, if you are a little unsure, another thing that sometimes can work is if you drag off from the component. Let's look up get local bounds. Let's split open the max bounds and use, in this case, we're going to use, I think, the X value. And just plug that in, and it should work the same way. Now, one more thing we need to do is do the driver pull. The driver pull basically tells us what vectors on this driver we're going to take into account. For example, if we only have the X vector, then it's only going to build along the X axis. If we include the Y vector, it'll build along the Y and X axis. So as an example, let's just go ahead and make this a variable to demonstrate. I'm going to go ahead and say pull along X and Y. So now if I pull this along, there we go. I'm moving it on the wrong axis, but I guess it's the Y axis. Let's see. I may have forgotten how to do this because it's only pulling along one axis. Give me a second. Oh, I think I am forgotten specifically how driver pull works, but it is that technically working as I want it to. Essentially, you just add the pull to know which direction it's going to go. In this case, we're going to go the X direction because that's the way the wall is facing. And so now I can pull this driver along, and it'll just naturally build the wall as whatever I need it to be. And let's see, yeah, and that's all this right there is just with this one function. Plug that in and it's organically building the wall. Super simple. I can also just delete this, like I said, 400 I think is the distance, and it should still build naturally. Yep. So if we want to add in the separators, what we can also do is same thing and plug in the separators, and now look at that. Now we already have a wall with just these two functions. With outside of me explaining, it could take like 20 seconds, and you already have a function that normally would probably take I don't know, a couple minutes to make. But then that's also minutes are going to add up because you may want to add the same system across multiple functions. And then what do you use a component? Do you clamp it to a new function? Well, I've kind of already done that for you. So yeah, that's the first method for doing that. Let's see. Now, a wall is all fine and dandy, but what if you don't want to have just one wall? What if you want to have four? What if you want to make an entire room or a house or something? Well, there is a function that'll automatically do this, adding mesh instances along a driver, but it'll do it along all four angles to create essentially a room or a house. So to do that, let's go ahead and add look up. I think it's build mesh box from driver. Now we're gonna do the same thing. Add in the wall, add in the driver. It's our distance. It's 400. Here we also have our height though, because height will determine how high up we want to build it. Because it's essentially going to stack these on top of each other depending on how high they are, and I believe it's also a height of 400. So now, if I do that and look at this, where is it? Is it doing it the right way? Is it negative? Huh? It's not building. I wonder what did I miss? Okay, this was working just a minute ago. Hey, look, real-time errors. Oh, I know what the problem is. Right, because I'm not high enough. Boom, there we go. So now look, it's building walls along 4 axes. Now, this is a bit strange because what you're seeing here, and I will actually just go ahead and here make it a default value so you can see it a bit better. Boom. What you're seeing here is that it's kind of building weird. Some of these are on the wrong axis. This is essentially going to happen when you have a kind of the idea is that depending on the mesh you use. Zephaniah, hello, welcome. We're going over World Mason, which is my new plugin, and kind of how to use it, and we're showing you how to make a house or a room. Anyway, as I was saying, the reason, even though we have this function technically working and building along all 4 axes or sections, the reason it's not working is because depending on it automatically is going to kind of assume that how do we say this? Words. Basically, what is happening is that you see where the wall is. Well, the wall's pivot point is right here. Nope, and I can spin the whole thing around. It's essentially building along the pivot point, which works fine for. Well, so example, if I added a cube in, let's see, the pivot point is in the middle, so it's kind of building correctly. Everything's kind of evenly spaced out. We do have some overlapping there. But when I have this wall, the pivot point is on the end, so it's fine on the first 2, naturally, but it's not on the others. Now, depending on your mesh, this is maybe what you want. Not necessarily this layout, but if the mesh is centered. But in this case, it's not what we want. So, what we can do is we can go in, and we'll actually create variables for these. Because we have these 2 variables called apply flipped offset and apply offset pull. And admittedly, I'm going to have to remind my memory on what both of them individually do, but essentially there are ways of fixing this. So, apply flipped offset. We'll do that. It'll essentially flip the direction or the offset in which the negative sides are built. Never remind me what apply offset pull does. All right, apply offset pull essentially adds an additional pull to the meshes in case you need that extra bit of distance. Typically, I've used this on like rooftops for adding corners and stuff. Corners that don't just slot in but have to be their own mesh. Anyway, let's go ahead and apply offset pull. So now. Here we go. Now we can just build this however big we want. However, we are having these gaps here, which is kind of annoying. It's annoying to have to make sure it's exactly the right size every time. Well, one way we can get across that is, let's go ahead and add in, we have a function called clamp vector to step. What this does is it'll take in a vector value and then clamp it down to make sure it scales to a specific value that we give it, or that it's perfectly divisible by that value. And it can either return it as a copy, which means it'll come out this end, or we can reapply it right to the driver. I think it's typically safe to use this one, clamp vector size to copy, because the other, this one, let's see, clamp vector size to, clamp vector size to reference. If we use this, it would reapply the value we get right back to the driver, which can be useful in some cases, but it could also cause some building problems. So just to be safe, I'm going to use clamp vector to step. And because our size we're using here is 400, we're going to clamp it to a size of 400, which means every value is automatic, or every value it's basically going to take this and make sure it is evenly divisible by 400, so that when we spit that back out and plug it into the driver, there we go. No matter how big we scale this, it's always going to snap perfectly to size. And let's go ahead and make this a function. Actually, I got a better idea. What we're going to do is take this and we're going to say add a wall section. And we are going to do it again, but with the separators. So if everything's working right, look at that. We already have just that one function, and we just kind of duplicated it. We now have this thing that you would actually take quite a while to build normally. You can make rooms, you can make houses out of it, and we can pull it up, scale it as high as it needs to go. Now this is all well and good, but one thing you need in rooms and houses is doors. And there's currently no way to get in and out of here. So we have a couple functions that can work with that. One is we have, let's see, remove mesh instances from Boolean points. And what this does is we can give it in a mesh instance component, either one, our separators or our walls. We can then add in vectors. Let's make the vector radius 1. Let's go and make that show 3D widget. Let's say, we'll call it holes. And what this does is every single driver, every time we add a driver to this array, it'll find any, in this case, actually let's make it walls, not separators, any walls that are in this much of a distance from that point, and it'll remove them, creating a hole. So, let's go back here, add in a hole, and right there. Now we can just go ahead and add a door or multiple doors or whatever we want to this, and it's distance based on that particular vector. Now it is a little buggy sometimes, admittedly, but for the most part it works. You may have to get have it in a very specific position to make sure it's not overlapping an additional section. But there you go. Now you can add holes and stuff like that. Now this is good. But we can do better, because even at this point, if we wanted to actually have a doorway, let's see, you would still need to go in and manually add the doorway in right here, and that's kind of annoying. Have to do, like, all right, every time we add a hole, I have to copy and paste this. And again, it's not that one instance of this takes a particularly long time to do. Like, it doesn't actually take, like, it took me, what, 3 seconds there to just drag that in. And maybe an extra 3 seconds there, or 5, whatever, just to copy and paste it, move it. If I had another hole, say, just duplicate this one actually. If I had another hole right here, but when you're doing that, say hundreds or not thousands of times, potentially a day, to make lots and lots of houses and stuff, that time really adds up. Because that's kind of the thing about game development is a lot of individual things don't take that much time, but when you add up the amount of times you need to do that thing, it really adds up. So if you don't want to just remove a point, what you instead can do is this. Replace mesh instances at location, which functions essentially the same way, but it'll take that mesh, instead of simply removing it, it'll replace it with a mesh of another type. So for example, I'm going to go ahead and add in doorways. Let's look up that, doorways. Let's go ahead and use that one. And we're going to replace the wall mesh with the doorway mesh. And it's going to function the same way. So now, if I drag this out, let's get rid of the copies. And there we go. So wherever I place this hole, we now have a door there. And you can do the same thing for not just doorways, but any kind of hole you need. So I'm going to say this one will be doors. I'm going to make a new one. I'm going to call it windows. So let's make a new mesh called windows. We'll just call it window because right can't have the same name. Window. There. And we will replace any wall meshes with window meshes. Same thing. And now, let's go ahead and just, we have this boolean right here, we can just do it. Click a new one of those. Oops. And then we can just add in a window wherever we want it. Now, obviously, I picked probably not the best mesh because this is stone on wood, but you can use the wood thing and it works the same way. Sweet. There we go. And now I'm gonna use. Do I have Omega game framework installed? Well, if I go ahead and hit play, it'll do the floating thing. Look at that. We have a base for a house ready to go. And of course, it doesn't just need to be a house. It could be. You could do this for. Hang on. Individual rooms as well. It's like I just want to add a room right here. And let's give it a door. Oops. Make sure it's sliding on the right axis. Make sure it's on the right axis. We get 2 doorways. We don't need 2 doorways. Just the one. There we go. Look at that. Now we added a room. Well, I say we added a room. We do have a bit of extra walls here that we don't need. So another function for that is if we go back to add wall section. On this function, we can decide here which walls we want to use. So I'm just going to make these into variables so I can turn off those walls whenever I want. And basically, this just says, you know, do we want to use those walls? Do we want them to be active? So if I go ahead and Gabriella, hello, welcome. We're going over World Basin, which is a plugin I made just released for the Unreal Engine Marketplace a couple weeks ago. Just going over how you can use it to make stuff like this. Like I've made this house, and I'm making a new room for it. And essentially, I've done it with 2 functions. Aside from explanation, in about, I'd say 20 seconds, you could do this. All right. So now, like I was saying, you can go ahead and turn off certain walls if you don't want them, which I believe is these 2. And there. You can go. No extra annoying walls. Or if you just wanted to remove a wall entirely, hey, do what you want. Now, that's walls, but we are missing a couple other things here. So, for example, where are the floors at? There's no floor. And if I want to have multiple floors, what do I do then? Don't worry. We have a solution for that. Not only can you add things in a line or add them in a box, you could also add things in a tile formation. So let's go ahead and do floor tiles. Flute tiles. Floor. Yeah, that's a good one. We will say, I think it's build mesh tiles from driver. So that's the same thing. Let's take the, I'm going to go ahead and add this to a function. Get true scale. Go add our floor tiles. Oops. Which I believe will also have a distance of 400. Same thing, 400. Also, I don't know if I'll need to demonstrate these, but we also have offset location and offset rotation for the other ones as well. And that's just, of course, if your mesh is slightly misaligned and you want to rotate it or have it face a certain direction or whatever. Those are free to use. But anyway, let's plug in the driver. And now, actually, this is a good example of it. So now, look, and however how we move this, we get these floor tiles. So we can have a floor for everything. Obviously, it's dark because I think I have lumen turned on. I'm actually going to go ahead and turn lumen off just for demonstration purposes. because it'll actually look better without it, because I can actually see inside. Yeah. Or alternatively, Joey, hello, welcome. Alternatively, maybe you don't want a floor for, like, you don't want a floor to be on every scale. Like, you want to be able to scale this up and only have that one floor at the bottom there. What we would do is we have axis values we can use. You just turn off the Z value, and it'll only build an X and Y value. Now the floor is also, as you can see here, misaligned. So what I'm going to do is actually this offset distance. So I'd say it's about halfway, because I think the floor is centered. Might be. So what I'm going to do, I think it's on the X value. Let's try halfway on the X value. What happens to that? Nope, that's the wrong one. 200 on there. Okay, it's not. It's a full step off. So, and I used offset location. Boom, there we go. So now we have room. Oh, I mean, also you can decide whether or not you want floor or not, because here now I have an extra floor on this. In fact, use floor. And for this one, we will not use the floor. Excuse me. And of course, if you did want to have, I'll turn back on the Z scale. If you did want to have a, excuse me, gotta take a drink. My dry throat. If you did want to have this scale up like this, and you want to have a floor in every single level, well, you're gonna need a way to get up from floor to floor. Well, you can just use the same replace or remove mesh instances. In this case, I'm just going to use remove for the sake of it. But remove mesh instances from Boolean points. Vectors, radius 1, floor holes. Let's make a floor category. And if I add in floor holes, which need to be visible in editor. 1 second. Show 3D widget. Turned on. Floor holes. There we go. There you go. You can add holes to the floor. I'm going to do a hole, I guess, oop, in the corner there. And obviously, the meshes you use will depend on how things, on the results you get. Or sorry, the results you get will depend on the meshes you use. Like, this is a flat mesh, so it doesn't look great. You might want to use a different mesh for actual floors in that case. But if I look up, this is one area where you need to manually add in the stairs. I don't have a way of procedurally adding in stairs for stuff like that yet. But I just do stairway. Oh, we'll say there. Maybe add another one. And it's not perfectly aligned, but you get the idea. And you can just add more holes right here, or ideally you could just change the size of the the size of the holes. But there you go. Now you have this stairway up to the next floor. And that is an example of how you might make a house. And you could add other things like you could, this might get a bit more technical, but if you wanted to add a roof, you could use the same tiling method, or sorry, you would probably use like the floor tiling method, but only use the z-axis, and then you would also just want to set the location of the mesh instance for the roofs to be whatever the top of the scale is. So, yeah, that's an example of how you'd use houses. Now, that's one of the use cases we got out of this. Another case is that, hang on, let me remove that. All right. So that's an example of a house. You can also use that for kind of linear walls and stuff. But there's other types of structures you might want to make, like, say, kind of curved walls or fences. Or more specifically, you want to maybe build stuff along a spline. So let's go ahead and create a new one. And we're going to call this curved wall. All right, let's see. So let's go ahead and I'll just copy over the wall and separate a mesh from here. We'll add in a spline, and what we're going to do, make sure that's on there. We're going to say build mesh instances, or sorry, mesh instances. We're not going to do mesh instances along a driver node. We're going to do them along a spline. And we have two ways. We can do them at spline points, or we can do them along a spline. I'm going to use along a spline because I think that's a more commonly used one. Where we're just going to, let's say, plug in our spline, plug in our, let's say our walls for this one. Give it the distance, 400. And on this one, you actually can decide to automatically make it the distance from the from its x-bound scale or y-bound scale or whatever. I'm just going to keep it simple and use the distance as 400. The offset distance, I don't think I need offset distance for this. Let's see. And oh, look, we already have it. Let me check the spline. I'm going to make sure it's a big enough scale. We're already having that. Let's go. Now let's drop it in. And boom, you can build it along the spline. Very simple, very easy. Now, a problem is that when you say you want to curve a spline, that doesn't look very good. So because these are not if you are familiar with my multi-spline mesh component, it essentially is a way of having a spline mesh, which is a curved mesh, go along a spline. This is different from that. This does not have that functionality because that requires a separate component for every single instance on the spline, which in this case is kind of hard on performance, and it's just not included. So one way to fix this though is, well, this is where separators come in, or columns, which kind of break up each section on the wall. So let's go ahead and let's say collapse to function, add meshes to spline, and we're going to grab it off and just add on the separator. And there you go. I say there you go, but you might notice something is still off. We're covering up kind of the corners of it, but they're still misaligned because they're not like connecting to each other. Well, the way you'd solve the reason is essentially because what it's doing right now is it's telling the meshes to it's essentially just placing this mesh down along whatever the based on whatever the kind of the curve or the tangent at that spline point is, which means whatever the kind of rotation of the tangent of that point is, it's going to aim the mesh in that direction. Well, in the walls case, we don't want to do that. We want to aim to whatever the next section on whatever the next section of the wall is. The way you can do that is you have this aim to next point. So I'm going to drag that out. Make it, because I don't think I want to use that for both of these, though it may not matter. But for the walls at least, I'm going to check aim to next point. And now, look at that. And of course, I can do a closed loop, which admittedly does need, I think, a little polishing up because it creates an extra mesh. You essentially have to line it perfectly. That's essentially something I'm just going to need to fix in an update, but there you go. I will uncheck that closed loop for now. Now you have a nice wall along a spline. Now again, there are still going to be some restrictions on this for if you're using meshes like this. Like you have to make sure they're actually distanced correctly far enough from each other to where they actually are not, clipping into each other like this would, but it does still save a fair bit of time. Now let's see. Now that being said, there are some times where you'll have a mesh. Like actually, this is a pretty good example of it. Let's just make a new wall because I'm about to talk about something. Let's see. Curved wall 2. We'll delete this one. So there are other times where you wouldn't necessarily want this sort of even separation between. Hang on. You wouldn't necessarily want this sort of even separation between every point. What you would rather have is put these separators at every single spline point, so you can kind of control more where they're placed. So in that case, I'm gonna say add mesh instances to spline point. We're going to do that for the separators. Sorry, separators there at the spline. I don't think we need to do anything else in that case. So now we'll add one of these to every single point. where we place a spline mesh. And so we can add more where they go. However, for walls like this, that's not necessarily a great option because look, everything is kind of being misaligned. But what you might notice is that these walls are they're essentially all just flat. They're like a flat mesh, right? Even though they are like individual meshes, they don't necessarily need to be. Like, if depending on the shader we had, if we had a world align shader, we could have a mesh that was just one mesh that was this big and stretched along the entire thing. This isn't a great example, but you know, this section here could all be theoretically be one mesh like this. If you had the right shader, that was a world aligned, that had a world aligned texture on it too, it would still seamlessly populate. In fact, I'm going to check and see if this does. 1 second. This is a slight tangent. Nope, that didn't. That's for the floor tiles. I want to see the brick tiles. Okay, that's not world aligned. So, okay, well for now, I'll show world aligned stuff in a second because I have some goodies to show off in regards to stuff included with the plugin. But anyway, so say you still wanted these to connect seamlessly from point to point. So you couldn't use these sort of individual meshes because it would look weird. Well, at that point, an option that you have is, instead of using add splines as meshes, you can also use stretch instance mesh along spline, and this will essentially take an instance mesh and stretch it along the spline from one point to another. So every point will have a mesh stretched along it. So drag in our wall component with spline. I don't think we need an offset. So there, look at that, just two functions. Let's go ahead and compile. And look what we have here. Sort of same thing, but it's seamless in terms of the mesh transitioning from one point to another. Now, of course, this is not a good shader for this mesh because we want something that actually populates, that makes the bricks look seamless and not just really ugly and stretched out. Now, one thing that is included with World Mason is a couple of materials and material functions that you don't necessarily have to use, but you might find them helpful for creating materials, for example, that do this sort of thing. So I'm going to create a new thing called mat. Let's go ahead and make a new material instance. We'll call it WM wall 1. It's going to be for wall. And when you made the material instance, if you look under parent, let's look for World Mason, I think. World Mason layered shader. This is super simple. It's literally just a shader that uses material layers, which I won't go into, but if you're not using material layers, so you don't know what they are, I would really recommend it. They are great. They're powerful. They essentially allow you to, well, layer on different types of materials in a non-destructive manner. So we are going to use the the layered material shader, which is simple, and then just replace this material layer with what I'm going to use here is another one included. One of the material layer types included with World Mason, which is world aligned, which just takes a texture and aligns it along based on the world. So if I actually go ahead and add this, let's go ahead and add this to our curved wall 2 right now. Say World Mason wall 1. Compile it. You see, it's tiled there. Now we don't want to use this texture. We want to use an actual wall texture, which there should be one included. Actually, there was obviously several included, so I think it would be brick, actually. So grab that. We'll add in, you can't really see it. We're going to add in the actual normal map as well, and I'm going to change the tiling to 400, which is a bit big, but that's fine. And there we go. So now when we use that combined with that material, just combined with meshes, now we have this easily splinable mesh thing. And all it took was these two functions. In fact, I didn't even need to change anything, which means you just create a new actor, drop in these two functions, plug in the meshes, take just a few seconds, and you already have as many different variations of this type of wall as you could possibly want. You know, you just add in different materials, different meshes, and it all works great. Let me see. Was there something else I wanted to demonstrate with this before I moved on to some of the other stuff? Let me look through World Basin. Build meshes driver. There's a couple things you might notice in here, like build mesh box driver multi. This is essentially a way of taking in multiple components, multiple different mesh components. For example, if you wanted some randomization as far as if you wanted 3 different types of walls you wanted to kind of randomly vary between, then you just add them to the list here. You could add in a seed, which would determine which walls to select for which section, and it would randomize between them. I'm not sure entirely. Oh, actually, a quick thing. You have also an option for random order. You know what? Let me just demonstrate this. It'll be faster. All right. World Mason multi-wall. We'll call it whatever. Misspelling. It's fine. Let's go. All right. So just say wall or instance static mesh wall 1. So we have one type of wall there, and wall 2, and one more type of wall. Sure, the brick wall. These do not match, but that's fine. Like, they're not thematically matched, but that's fine. Let's say multi-mesh. Add mesh instance is a long driver. Keep the driver to 1. Instead of adding in just one mesh component, we're going to add on all of them. And same thing, just give it a driver. The distance between them will be 400. It only works for meshes of the same distance, obviously. So if I go ahead and drag this in, everything's working right, which it doesn't look like it is. So let me see what I'm missing. Is it actually height-based as well? This may be why I didn't want to show it, because I thought there were some issues with it, but let me just double check. Oh, driver pull. That's why. I had the driver, not driver pull. There we go. So now, as you can see, we can add multiple meshes instead of sticking to one specific type of mesh. Now, your 2 options here are random order or random seed. Random order and random seed. Now, if this is checked off, it'll just line them up in the order in which you place them consistently. So, like, we have type 1, type 2, type 3, type 1, type 2, type 3, type 1, type 2, type 3, yada, 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 yada. And this is the one I would say you can use it, but maybe be careful with it, because I'm not 100% sure if it works. Well, I say be careful. I mean, if you're wanting to do anything permanent, be careful with this, because it may have issues with, like, essentially permanently maintaining the order. But, the seed. If you click random order, then it should find a random way to populate this in. So let me just kind of throw that out. Yeah, this is what I was concerned about. I wouldn't necessarily use random order right now, because there's some issues with the seed generation, where it's supposed to be kind of randomizing what walls go where, but it's kind of using the same one, and I'm not sure why. So, but if you want to use multiple walls kind of in a repeated order, you have that function. All right. And there's a similar one for building along a box, and I believe one for building along a spline as well. All right, get rid of that. Get rid of that. If I just open this up, I need to look for see other functions I have. World Mason. Clamp, spline, tangents. Oh yeah, just one I'll quickly go over. This is essentially just a way of snapping down the tangents of a spline. If I plugged in this spline mesh here, to essentially make sure that there's no curve in it. If you understand how a spline works, this is useful if you want to have like a straight line on a spline, which I might show off in just a minute, actually. But let's see, World Mason. There's some other useful stuff like get vector corners, which this just gets kind of the locations of a vector that are at its corner points. Like if say we had if we had a driver here, if say the actor was here and the driver was here, then the corners would be at this point. Then it would also have get a corner here, here, and same, if the thing was here, it would scale it up as well. Essentially, it would convert the driver into a bounding box, and it would get you the corners of those boxes. which was good for adding like corner pieces, obviously. Anyway, World Mason. Get 2 deflector points from Spline. I think that's a utility thing. World Mason. You also have form spline as box and form spline as circle. This just, you may not use these much. They're essentially just ways of taking a driver like I showed you before, and then clamping a spline point, the points of a spline to that driver, to the corners of that driver. Let's see. You can offset mesh instances on mass. So if I plug this into the separator and did 200, then once all the points are set, it will, hang on, curved wall. Yeah, you can see it would automatically pop these up 100 or 200 locations in this place. That's another way you could add a roof. You could just make sure you add the roof tiles in, and then you just offset the location however high the driver is. Stuff like that. All right, let me double check through what I have. Append mesh instances at location. Oh yeah, so this is another one. This works similar to remove or replace mesh instances, but it doesn't remove the original. It just adds a new mesh instance to that location. So, also useful. All right, what are we at? 150. We're getting close to an hour. So I think the last thing I want to talk about is using dynamic meshes. So, one of the things I demonstrated in my, well, let's just do this. Spline block. One of the things I demonstrated in the Circle of Orion devlog is how I essentially use what I call a spline block to essentially build an entire mesh section from a spline dynamically. So in order to do that, what we'll need to have is a dynamic mesh. A dynamic mesh, which remember requires geometry scripting plugin to be turned on, which should be automatically be turned on with the World Mason plugin. But yeah, I'm also going to go ahead and set the collision to use complex as simple, enable complex collision, and defer collision updates. Sorry, I'm a bit tongue-tied. Let me take another drink. All right. Anyway, let's grab that dynamic mesh. Let's pull it out. Oh, let's add in the spline too, because we're going to need that. Just to start off with, I'm going to make sure that this spline point has 4 points, and we want to make it a closed loop. Closed loop, there we go. And this is one area where I'm going to say, well, I'll do that in a second. Alright, so now that we got our dynamic mesh, we need to get our dynamic mesh. I would recommend kind of understanding a little of how geometry scripting works, but if you don't, it's still fine. What you'll need to do is get in a dynamic mesh component, just do get dynamic mesh. Then let's look up under World Mason, we'll look up build, I think it's spline. Build dynamic mesh along spline. Here we go. Plug that in. Let's plug in our spline. Let's give this height. That'll determine how high it can go. And now we drag this in. Well, let's set the default height to 100. Look at that. We have a box that'll dynamically build along our spline. And this is how you can add really specific what's the word? Really specific stuff, blocks to your game. Let's just drag it out. Give it some weird shape like that. Also, because we made height a variable, we can change the height of it. In order to make collision working, you will also need to, I'd say, on event begin play, don't do this on construction script because it will cause performance problems. But I think it's update collision and turn off only impending, if pending. So that should update the collision so it should actually work. So let me go ahead and test it out. Oh, it doesn't work because I'm a floating guy? Hang on, why did that not? Oh, I know why. Well, it's a mesh, so you still gotta set the collision to whatever, block all in this case. Boom, there we go. Collision works just fine on it. Now, the UV mapping on this is kind of haphazard, and that's sort of by design because it's intended to work with Well, that it's like the material I showed before. So let's go ahead and grab that. Well, actually, we have to add on the map. I may to add a material to a dynamic mesh. It's a little weird. You have to do set material, I think. Set override render material. There's not just an option normally in here, but it works basically the same way. So let's just go ahead and plug that in. Set material. And let's look up our wall. World Mason, I think. Yeah, look, there we go. And there's our wall material working on it. So you can add on that. And of course, just this being a layered shader, I'll go ahead and add a floor section to it as well. Come on, where are you? There we go. For adding walls and floors to a layered material, I will use the vertex normal. Set it to the blue channel, because the blue channel in RGB is from the top. So I'll also do contrast. The offset's fine. Offset probably doesn't matter. Anyway, let's just add a floor texture. Oops. Floor. Tile. What options do we have? Paving tiles. We'll just use that. And set the tiling on that also to 400. 400 just so it's not super tiny. And saving. Well, look at that. Now we can build this kind of however we want. And we can... Hang on. We can duplicate that or add a new one. Increase the height. And see, we can get really specific. And even if you didn't use this in your final version, because depending on what type of game you're making, you may not need this. This is super helpful for blocking because it doesn't require you, instead of needing to do something like, all right, I want to block out some walls, so, or to block out where the bounds in my game are. So I need to add a mesh here. Let's copy it, line it up perfectly right there. Let's copy it again, line it up perfectly like right there. Again, it's shaving off those precious few seconds in each individual instance will over time save you a lot of time. Because now what we can do is just... hang on. Oops, that was a bit too far. Oops, wrong way. Whoop. And up the height. And we've essentially just done the exact same thing. And when we're doing that over and over and over again, that adds up, which is why stuff like this is important. And let's see, the World Mason wall material. Sweet. Look, it's already kind of a blocked area. And of course, because we're working on a spline, we can add extra things to this, like... what do we add? Instant static mesh components. Let's say, I think we have a fence, right? Yeah. Add mesh instance. Add mesh instances along spline. Just use the same spline we did before. 400 will be the value. Although I think that's too big for this. Yeah, that's too big. We want a value of 200. 200. Make sure we do aim to next point, I think. No. Not aim to next point, because this one's centered, so this will be fine. Oh, yeah. Clamping stand. This is where that clamp spline tangents that I mentioned earlier would come in. Let's do clamp spline tangents. I'm going to make this really small. Not exactly 0, because I find that causes trouble, but I'll do something really small, like 0.1. There you go. Again, this isn't exactly perfect, but depending on... You may want to use a different mesh than this one for it. They're also... These are at the bottom, so... Instead... Oh, I got a better idea. Why don't I demonstrate how you might make your own sort of fence from scratch? So instead of, let's say fence say fence post and fence railing. Now before I add those in, actually, I want to show you, see these are at the bottom now, and they don't scale with the height. It's a pretty easy solve. On here, offset location, let's break that in. And let's make the offset Z whatever the height is. And now, there you go. Whatever the height is, it goes along that. Now, as far as making our own fence from scratch, so we don't want to have to, worry about that stuff, what we can do is instead, let's replace, let's see, fence posts. Fence, we have a fence column right there. There we go. Excuse me. So we're going to do that. And maybe I'll make these a bit smaller. They are a bit big. Ooh. Literal float. Cut them in half. And we'll actually make them closer together. So we'll go for a point of 100. There we go. And now, for fence railing, let's just, what do we have? What do we have we can use? It's kind of like a rail. It's like a long post is kind of what I'm thinking. A long horizontally faced post. Maybe prop? Let's see. I'm not seeing anything I can use just yet. Well, oh, here we go. This can work. So let's grab that border. We're going to make that what we're going to use for the railing. And let's do the stretch instances along spline. Mesh components. Drag in the spline again. And, okay, that one's not aligned at the corner, so that's why we're going to get this weird result. Oh, but I know how to fix that. Let's just create a copy of this. And we'll use Unreal's. This is something I do commonly. It's not part of a World Mason, but it's a common thing I will use when I need to edit something quickly like this. Let's just go into modeling. Let's grab the pivot point. And I think we set it to center, not center. Right, bottom, top, front. There we go. Accept. Now we have modified that mesh to where its pivot is there. Let's go back and make that the only one to use for the railing. Also, I don't think we want to have the exact same height offset, but if we go back here, look at that. I say look at that. 1 second. We want to add a little bit to the height because we want it to actually be a railing. So let's say 50. It's probably getting closer to 100. Yeah, so 75. And look at that. We've made our own fence. And you can also, you can use these, I said you can do this thing. I'm just going to do this thing. I can use the same thing, fence posts. Add mesh instances at spline points. Plug that up. Get our height variable and just, oops, hang on. Offset location again. I have 2 spline points. That's why that was weird looking. And again, the mesh you use will determine how good this looks, but this is more to show it can function. Now look at that. We have this spline block. We can use right here. Oh, right. Something I need to change because this is how Unreal splines. On the spline point, make sure override construction script is turned on. And now, look at that. A seamless. I need to add the right material in. I'm dumb. It's okay. It's not a flaw. It's just I forgot to do that. And there we go. And of course, if anyone has questions, I'm going to be probably wrapping up the stream soon here because it's been about an hour. I've shown off most of what I want to do. So if you have any questions, just go ahead and toss them in right now before I finish everything up. Let's see. There we go. Look at that. Now, how many functions do we had to use that? 1, 2, 3. And most of them are just doing the same thing. Just offset it, the height location, offset height location. This one's a little bit more complicated, but even then, that right there. That's all you need for this, and that's way simpler than what you'd need to do in blueprints, where you'd have all these for loops and cross references and stuff. So there you go. And of course, you can add the remove these with the vector points like I showed you before, and create maybe add in a bridge if you want to. And so yeah, that right now is all the main things you can do in World Mason. So we got things like let's see, you can build kind of these nice curved fences and walls. You can add more curved fences and walls on the spline points. You can which you can also use like for like bridges and stuff. You can have the spline block. We have houses, a pretty advanced house and a room thing, and just between that, you have a lot of the things you'd need in order to like start very quickly populating elements of your level, adding things like that. I mean, honestly, there's no real rhyme or reason to it, but right now already I could see this being a block out for a level or an area in a game. Obviously, you'd need a lot more detail, but like if we're just to start with, this is not looking too bad, honestly. Yeah, so there. That is World Mason, ladies and gentlemen. At least as right now. Since I'm using it in Circle of Orion, I will be adding more functions and stuff to it as time goes on. I've had a couple of requests for functions already. One, for example, that I've been considering is a, and I don't know how if this would quite work for World Mason, but we'll see. Something that would try and convert every time you have a matching static mesh instance in your level, it'll automatically convert it to a instance mesh in order to save on performance. Though I don't know with Nanite and stuff like that in Unreal 5 if that'll really be necessary, but at least having it as an option might be cool. But yeah, so that's where it's at. That's what you can use it for. Once again, let's see, pull it up. Unreal Engine World Mason. Search results don't seem to be... YouTube search results and stuff don't seem to like it, but if you just look up World Mason level creation tools or go to Studio Syndicate on the Unreal Marketplace, you should find it right there. And I believe the price point is about $30 for the whole thing, and that'll at least... Okay, I'm not going to say anything about the price point in the future, but I don't have any intentions on raising the price right now. It'll be $30 indefinitely, because that's essentially, it's just more of this will be what I'm adding. So yeah, that looks useful to you at all, be sure to go check it out. Also check out my other stuff. I got a lot of stuff on here. Some of my classic stuff like the 3D platformer toolkits, Super RPG framework, stuff like the anime character pack. Omega game framework is obviously free. Some of the add-ons that come with it. We have battle scene transitions, multi-spline mesh component, and the new advanced spline volume, which is a kind of works similar to the spline block I just showed you, though it handles, well, it can handle all sorts of things. Basically, it's for triggering events when your player character walks into or walks against custom volumes along a spline. So, also be sure, subscribe. You watch my devlog for Circle of Orion. And yeah, thank you all for coming on the stream. I really appreciate it. All the support you guys give me, it's what keeps me going, especially the financial support. Being able to, even if you don't use my stuff, if you'd like to financially support me, I have links for stuff like Subscribe Star and Coffee in the description. But the best way to support me financially would be to buy any of my products on the marketplace. So yeah, that's all I got for today. Once again, thank you all for watching, and I will see you all next time. Take care, guys.